All right, so we are continuing with day 9 notes, and there are two types of discontinuities that we need to focus on. First one you have is a jump. So let's take a look at a jump. A jump would be something like this, where you're going from one y value and jumping to another y value. This would also be considered a jump. This one is not a jump, where the y value is almost to 1, and on the other side, you're almost to 1 coming from this direction. So we have a jump, and then we have what we call a point discontinuity. So this would be a discontinuity because it's at a point that there's an open circle. All right. So with a jump, the two pieces don't connect. With point, the two pieces connect. At an open circle. Okay. So I want to take a look at the fact that we have f of x, g of x, h of x, and p of x. So with that, we are going to be answering the questions on page 44. So these next two pages focus on the graphs of right here. So let's take a look at the f of x graph. It says, what type of discontinuity occurs in the graph of f of x, and what x value does it occur? And at what x value? So we have a jump. These two pieces do not connect. So we're going to say jump. And the jump is occurring when x is equal to 3. And I want you to pay attention to the 3 and the 3. Notice that one ends when x is 3 and the other one begins when x is 3. Is f of x defined at this value? So according to this, if I look, there is no defined y value. So I'm going to look and say that f of positive 3, so f of 3 is equal to undefined, because when x is 3, there's no closed circle. If I were to plug in 3, I'm still going to get 2, it's just open. And this one right here, I plug in 3, I'm going to get 4, and it's also open. It says, by investigating the constraints, right, the domain, right, this right here, these are the constraints. So by investigating the constraints of the equation, the first piece of the graph of f of x will stop just shy of x equals, we're going to stop right before we get to 3. And the second piece of the function will begin just past x is equal to 3. Complete the following statements according to the graph. Again, as x approaches 3 from the left. So I want to be very clear when you're dealing with this. You are approaching from the left of 3. So you are on the left side of the 3 on the number line. So on the left side of 3, you are approaching a y value of 2. Right? Approaching 3 from the left, the graph of f of x is getting to be a 2. On the next statement is saying, as you approach x, x approaches 3 from the right, what is the y value? So I am on the right side of 3. So I'm coming this way, and I want to look at the y value on this side of 3, on the right side of 3. The y value is 4. Okay. So it says, using the equation of f of x, determine the y values that each piece approaches from the left and to the right. So we're going to phrase this as x approaches 3 from the left, f of x, and remember what function we're in. We're going to be in this function because we're approaching it from the left. So we are going to write the function down, and instead of putting x, we're going to plug in 3. 3 plus 3 minus 4. That's going to give us 6. Absolute value of 6 is 6 minus 4 is 2. And then we go as x approaches 3 from the right, which means I am going to be in my linear equation. I'm going to write down that equation as negative 1/3 x, and in this case the x is 3. Negative 1/3 of 3 is negative 1. Negative 1 plus 5 is 4. So here we go. Since, this is the analysis part, since both pieces approach different y values, then f of x has jump discontinuity at x equals 3. Now let's take a look at g of x. What type of discontinuity occurs in the graph of g of x, and at what x value does it occur? So if I take a look at the graph, let me go on here without, go back a page. So as I'm going here, stop here, and then this one continues. Okay. Just want to make sure we are good. This is on the break in the domain, essentially, not even really a break in the domain because this one's defined, but the break in the graph, all right? It's discontinuous when x is equal to negative 3. Looking at that graph. So what type of discontinuity do we have? We have a jump at x is equal to negative 3. Is g of x defined at this value? In other words, is there a defined y value? Yes, there is a defined y value because there is a closed dot. In other words, I could go back into this function, plug in negative 3 because it's equal to, and figure out that exact y value. So g of x is going to be defined. If so, what is the y value? From our graph, we can definitely tell that the y value is negative 2. But what we're doing is we're plugging in negative 3 into the equation. So we get negative 3 plus 6 squared plus 7. We get 3 squared is 9, negative 9 plus 7, and we get negative 2. Okay. And so we could have also looked at the graph and saw that the y value was negative 2. By investigating those constraints of the equation, remember the constraints. These are the constraints, right? By investigating the constraints of the equation, the first piece of the graph of g of x will stop at x is equal to negative 3. That's where it's stopping. And the second piece of g of x is going to begin just past x is equal to negative 3. Just past that on the other side. Complete the following statements according to the graph as x approaches negative 3 from the left. So we're coming from the left of negative 3. The y that we are approaching is negative 2. As we approach -3 from the right, which means we're on the line because we're on the right side of -3, the y value is -4. So we're going to use the equation to determine the y values that each piece approaches from the left and to the right of x equals -3. So as x approaches -3 from the left, g of x, and remember we're using the proper function, it's that parabola. We just did this calculation right up here. And then as x approaches -3 from the right, now we're going to use the other function. Okay, so we've got the other function was defined as that radical. So negative square root, instead of x, we're replacing x with -3. -3 plus 3 is 0. Square root of 0 is 0. The opposite of 0 is 0. And then 0 minus 4 gives me -4. Okay, they do not have the same y value. Okay, so since both pieces approach different y values, then g of x has a jump discontinuity at x equals -3. All right, now let's take a look at h of x and p of x. Again, these are the graphs. So we have h of x and p of x. It says what type of discontinuity occurs in the graph of h of x. So if I were to take a look, I want to be able to see h of x. We can see that h of x has a point discontinuity. We can see that this side approaches that open circle, the right side approaches that open circle right there. So we've got what we refer to as point at x is equal to, and the x value of that open circle is -1. So is h of x defined at this value? No, there's no defined y value. You can also look at your constraints. Notice that it's not equal to -1. So we've got h of -1 is undefined. Now it says by investigating the constraints, the first piece will stop just shy of x equals -1, and the other one will begin just on the other side of -1. So let's take a look. As x approaches -1 from the left side, we are approaching a y value of 1. And as we approach from the right side, getting closer and closer to x equals -1, the y value is +1. So using the equation of h of x, determine the y values that each piece approaches from the left and to the right. So again, we're plugging it into the equation. Here we use the graph, now we're using the equation. So as x approaches -1 from the left, h of x, and again, I'm just using the function right here, the absolute value of x plus 4 minus 2, but instead of x, I'm plugging in -1. And then I'm calculating, that's going to give me a 3. The absolute value of 3 is 3 minus 2, and I get 1. As x approaches -1 from the right, I'm going into the other function. I'm plugging it into the quadratic function. So -1 minus 1 squared plus 5. Simplifying that gives me -2 squared is 4. That gives me -4 plus 5 is equal to 1. And the sentence that's going to connect them is, since both pieces approach the same y value of 1, since both pieces approach the same y value of 1, but h of negative 1 doesn't equal 1. So they both have 1, but the function itself is not defined, it's not closed at negative 1. Then h of x has a point discontinuity at x equals negative 1. All right, last one, p of x, right? We got 3 pieces, okay? So we've got a line, we've got a horizontal, a point, and then we have another absolute value. So what type of discontinuity do we see and where? So there is an open circle when x is negative 3, so that's going to give us point discontinuity at x is equal to negative 3. Is p of x defined at this x value? So is there a defined y value? Yes, the y value is negative 2. So p of negative 3 is negative 2. Okay, in fact, I could plug in negative 3. That means I get negative 2. We're looking at the constraints. The first piece stops just shy of negative 3. And the second piece, which really is this one, because this one is just a point, this one begins on the other side of negative 3. Now, if I take a look at this, I'm going negative 3 from the left. So the left side of negative 3, the y value is 2. On the right side of negative 3, the y value is also 2. So both of those have a y value of 2. Now we're going to connect everything here. Using the equation, determine the y values that each piece approaches from the left into the right. So as x is approaching negative 3 from the left, p of x, and I'm plugging it in to the linear equation, 1/3 of negative 3 plus 3, and then just simplify that, that's negative 1 plus 3, which gives me a 2. As x approaches negative 3 from the right, p of x, and I'm plugging it into the absolute value. I'm simplifying the negative 4, which gives me 4 minus 2 is 2. And we can say this right here. Since both pieces approach the same y value of 2, but p of negative 3 does not equal 2, then p of x has a point discontinuity at x equals negative 3.